And now let's try to solve a question based on this concept. So here we go. Let's read. There is a disk of mass m and radius r which is rolling without slipping from rest down an inclined plane. The angle of the incline is theta. Moment of inertia of the disk is given. We need to find the value of linear acceleration as well as the net torque. We have already derived the expression for linear acceleration. So in MCQ questions, you can directly apply that formula. But let's say if this question comes in the form of a descriptive question, then please do not apply that formula. We'll have to go step by step. We'll apply F net is equal to ma. Then we will apply the net torque is I alpha. And the third equation, remember, is A is equal to R alpha. So in a descriptive question, of course, you will be marked on the steps, but this is an MCQ question, so we can directly apply that acceleration expression, which is equal to, let me write, g sine theta was the numerator divided by the denominator was 1 plus I upon mr square, where I is the moment of inertia, which is given in the question as mr square by 2. So if we replace I with mr square by 2, the expression will become g sine theta is in the numerator. We'll get 1 plus 1 by 2 in the denominator. Now the denominator 1 plus 1 by 2 is nothing but 3 by 2. So let's write g sine theta divided by 3 by 2. Now this 2 can go in the numerator. So the final expression for the acceleration, let me write on the top, it will be 2 by 3 g sine theta, which means now if you look at the options, it is either option A or option B. C and D are definitely out. Now we need to figure out the net torque. How do we do that? We have already discussed this. To identify the net torque, we need to identify how many forces are acting on the sphere. So let me repeat. The first force is mg, the weight of the object, weight of the sphere. Then the normal reaction, which is perpendicular to the incline. And since the incline is rough, so friction will act up the incline as shown. Now coming to the torque, torque due to mg and torque due to n will be 0 because mg and n, both these forces are passing through the center of the sphere. And center of the sphere is also the axis of rotation. And the concept was if the force passes through the axis of rotation, then the torque of that force about that axis will be 0. So torque due to N and mg, they are 0, but the torque due to friction, we just use Rf sine theta. So like we earlier discussed, torque due to friction will be Fr sine 90. Sine 90 is 1. So the torque due to friction will be just F into R. And if you look at the options, option A has friction F. This expression, capital F with a suffix of F, this actually represents the force of friction. So we are multiplying friction with R. That is the torque due to friction. And that is why answer is A. A is the answer to this question. So this was an MCQ question where we applied the expression directly. But as I told you, please do not apply the expression in a descriptive question. So now let me show you that type of descriptive question which is based on this concept. So here we go. Please take your time, read the question very carefully, try to do it on your own, and then only proceed ahead to see the video solution. So here we have a hoop of mass m, radius r, moment of inertia mr square. Its moment of inertia is already given, rests on a rough plane. Since the incline is rough, which means it is going to rotate. The hoop is going to rotate. The angle of the incline is theta. Now it is mentioned that this hoop is released so that the hoop gains linear and angular acceleration by rolling without slipping down the plane. Now there is a significance of without slipping, which I will explain in a little while. But for now, let's go to part A. On the diagram, draw and label the forces acting on the hoop. That is simple. There are three forces acting on this hoop: mg, weight acting downwards, normal reaction, and friction. And let me show you how they have drawn the free body diagram in the marking scheme. So you can see W is the weight acting downwards. Then we have normal reaction, and the force of friction is acting along the incline but acting upwards. And please do not get confused with this line which they have drawn. The force of friction will start from the point of contact. So the frictional force needs to start from here and then it will go left. So please ignore this line which they have drawn in bold. So let me summarize. Weight mg will act from the center. Normal reaction will also pass through the center, but normal reaction also starts from the point of contact. Remember, normal reaction is a contact force, so it is applied at the point of contact. Similarly, the force of friction is also a contact force. Friction is going to be applied from the point of contact. And this is how we draw the free body diagram, part A. Part B, show that the linear acceleration of the hoop is given by this equation. And this question is a 4 marker, which means please do not apply that expression which we have derived directly. We need to derive that expression. So let's do that again. Remember the steps. We will start with the net force is equal to m into a. That's step one. Step number two is the net torque is equal to I into alpha. And then the third step is the relation between linear acceleration and angular acceleration, which is A is equal to R alpha. And how do we find the net force? Let's draw the free body diagram here also. Mg acts downwards. We have normal reaction, which is perpendicular to the incline, passing through the center of the sphere. And then we have friction, which is acting along the incline, but up the incline. Now, to identify the net force, remember the concept, net force needs to be found along the direction of acceleration. So we had broken the mg into components. So the component of mg perpendicular to the incline we had discussed, this was mg cos theta, and the component of mg along the incline, that will be mg sine theta. So the net force acting on the sphere will be mg sine theta minus friction. So let me write for the net force, we will write mg sine theta minus friction will be equal to m into a. So this is the first equation. And now, since we are supposed to find the acceleration of the hoop, let us try to make a as the subject like we had done earlier. So the expression for a will become g sine theta minus friction upon m. So that's the equation which we get from F net is equal to ma. Now coming to the net torque is equal to I alpha. The net torque, like we discussed earlier, it is just the torque due to friction, which is Fr sine 90. So we write F into R, that will be equal to I into alpha. I is the moment of inertia, which is given in the question as mr square. So let's replace I with mr square. So we will write Fr is equal to mr square into alpha. 1r will get cancelled out from both sides. So let's cancel out 1r from both sides. And then we come to the third equation, A is equal to R alpha. So what we'll do, let's try to make alpha as the subject. So alpha will be A upon R. And let's replace this alpha over here. Let's see what we'll get. So the equation which we got from the torque net is equal to I alpha was Fr is equal to mr square alpha. And now we are supposed to replace alpha with A upon R. So let's do that. F into R will come out as mr square multiplied by A upon R. And if we just simplify this expression, the r's will get cancelled out and the expression for friction will be m into a. And now we will replace the friction expression in equation which we got from F net is equal to ma, which was this g sine theta minus F upon m. Hence, the final expression will be A is equal to g sine theta minus A. And now if we try to make A as the subject, so what we'll do, we will take this negative A and take that on the left hand side. So we will have a plus A on the left hand side, which becomes 2A. So we will write 2A is equal to g sine theta. And let's make A as the subject, which is g sine theta upon 2. And that is what the question wanted us to prove. The expression for linear acceleration being g sine theta upon 2. And that is how we solve descriptive based questions. Remember the steps. F net is equal to ma along the direction of acceleration. Step 2, apply torque net is equal to I alpha, but along the center of the sphere. And the third step is using the relation between linear acceleration and angular acceleration. A is equal to R alpha. And if we apply all the three steps, that is when we are going to get full marks. All right, moving to part C, which is just a 1 marker, which means that should be easy. Calculate the linear acceleration of the hoop when theta is equal to 20 degrees. So all we need to do is just put theta as 20 degrees in this expression. So A is g sine theta by 2. Let's write A is equal to g is 9.8 sine of 20 divided by 2. And now if we simplify this, we will get the value of acceleration as approximately 1.68 and the unit is meter per second square. And that is the answer for part C.